What specific problem does the method introduced in this paper aim to solve regarding the evaluation of LLM-judge benchmarks?
The method introduced in this paper aims to address the problem of implicit biases present in LLM-judge benchmarks, which prioritize stylistic preferences over critical alignment considerations such as factuality and safety. The authors establish a common framework for systematically evaluating LLM-judge pipelines and analyze potential confounds at each stage, revealing that LLM judges exhibit powerful implicit biases that can distort evaluation outcomes. To complement existing benchmarks, they introduce SOS Bench, a new alignment benchmark with ground truth designed to measure progress on alignment principles of helpfulness, honesty, and harmlessness. This approach seeks to provide a more objective and comprehensive measure of model alignment, countering the limitations of LLM-judge benchmarks that may not accurately reflect human preferences or model performance. Ultimately, the paper emphasizes the need for robust and careful benchmarking to instill confidence in the results of preference optimization methods.
How does the proposed SOS Bench method work? Please illustrate its construction and evaluation mechanism step by step, including the principles it incorporates for measuring alignment.
The SOS Bench method is constructed by combining 19 existing benchmarks that assess various aspects of LLM behavior, specifically focusing on world knowledge, instruction following, and safety. Each benchmark question contains ground truth answers, and the results are aggregated using the average of normalized accuracies, reported with 95% confidence intervals. The evaluation mechanism involves testing models on a substantial dataset of 152,380 data points, which is significantly larger than previous benchmarks, ensuring reproducibility and standardization. SOS Bench incorporates the widely recognized helpful, honest, and harmless principles as its foundational criteria for measuring alignment, where a model is deemed better aligned if it statistically outperforms another model across these three factors. Specifically, a model is considered more honest if it demonstrates superior world knowledge, more helpful if it excels in instruction following, and more harmless if it shows better safety performance, thus providing a comprehensive and objective measure of alignment.
Can you provide a concrete example of how the SOS Bench evaluates a model's performance on a specific criterion, such as honesty or helpfulness? Explicitly detail the steps involved in this evaluation.
SOS Bench evaluates a model's performance on specific criteria like honesty and helpfulness by utilizing a structured approach that combines multiple existing benchmarks. For honesty, the evaluation involves measuring a model's performance on world knowledge tasks, where a model is deemed more honest if it exhibits statistically superior performance on these measures. For helpfulness, the evaluation focuses on instruction following, where a model is considered more helpful if it correctly understands and executes instructions better than another model. The process includes aggregating results from 19 different benchmarks, ensuring that all questions have ground truth answers, and reporting the results using normalized accuracies with confidence intervals. This systematic aggregation allows for a holistic view of model performance across the defined criteria, thereby providing a concrete measure of alignment with the helpful, honest, and harmless principles.
What are the practical implications of the findings regarding the preference optimization (PO) methods and the importance of data scaling highlighted in this work?
The findings regarding preference optimization (PO) methods emphasize that data scaling during the supervised instruction fine-tuning (SFT) stage is a critical factor for improving alignment in language models. Specifically, the research indicates that both the scale of data and the diversity of prompts are the strongest predictors of downstream task performance, surpassing other factors like curation methods. This suggests that researchers should prioritize large and diverse datasets when fine-tuning models to enhance their instruction-following capabilities, which is a primary goal of alignment. Additionally, the study reveals that while PO methods can improve safety and instruction following, they may inadvertently degrade world knowledge, highlighting the need for careful consideration of the datasets used in preference optimization. Overall, these insights advocate for a more robust and standardized approach to benchmarking PO methods to ensure reliable improvements in model alignment.
What experimental methodology did you use to validate the effectiveness of the SOS bench compared to existing benchmarks? Discuss the datasets, metrics, and results obtained during this process.
To validate the effectiveness of SOS bench compared to existing benchmarks, we conducted a comprehensive evaluation using a large-scale meta-benchmark that combines 19 existing world knowledge, instruction following, and safety benchmarks, totaling 152,380 data points. This approach is nearly 7 times larger than the previous largest open-source LLM benchmark, Hugging Face's Open LLM Leaderboard 2. We focused on 3 key factors: world knowledge, instruction following, and safety, reporting results using normalized accuracies with 95% confidence intervals. The results indicated that data scaling during the supervised instruction fine-tuning (SFT) stage significantly improved alignment, particularly in instruction following, while also revealing that preference optimization methods tended to degrade world knowledge. Overall, SOS Bench provided a more reliable and standardized measure of alignment progress compared to existing evaluations, which often suffered from issues of reproducibility and cherry-picking results.
In light of the findings in this paper, what limitations or challenges do you foresee in the implementation of SOS Bench, particularly regarding implicit bias and generalizability across different models or tasks?
The implementation of SOS Bench faces significant challenges related to implicit bias and generalizability. Firstly, LLM judges exhibit powerful implicit biases, prioritizing stylistic preferences over critical alignment factors like factuality and safety, which could skew the evaluation results of SOS Bench. Additionally, the reliance on LLM judges introduces confounds, as their preferences may not consistently align with human judgments or static benchmarks, raising concerns about the validity of the scores generated. Furthermore, the benchmark's effectiveness may vary across different models or tasks due to the inherent biases in LLM judges, which may not reflect the diverse requirements of various applications. Lastly, while SOS Bench aims to unify existing benchmarks, the challenge remains in ensuring that the criteria used for evaluation are sufficiently comprehensive and applicable across a wide range of contexts, as the current focus on a limited set of principles may overlook other important aspects of model performance.